So here is the design view. So first is we add axis here. Here will be the graph will be shown. It is called exponentially decaying signal. So the y-axis is named amplitude and the x-axis is named time in milliseconds. So we have four inputs. The first is the samples, where will the user put the samples. Second is the amplitude. Third is the time in milliseconds, and the fourth input is the sampling frequency. So after that, we added two button where the user will click. First button is the plot button and the second is the reset button. So for the plot button, we added callbacks. So you can see here in code view the callback of the plot button. So the amplitude, it is multiplied by 0.1. The time is divided by 1000 since it is in milliseconds, and the samples is just a input of value. So basically this for function is just the input, and the output is um, the formula for amplitude, which is this, what we learned from the previous laboratory experiments. So in this line, this is just the plot where what will the user see in the box. And for the reset button, the callback for the reset button is this up. The amplitude edit field value is equal to 0 times edit field that value is equal to 0 samples edit field value is equal to 0. So basically this reset button will just reset the input values that the user input in the box. So let's try to run the program. So here is the program. So for the first input samples, for example, we input 650 samples. For the amplitude, we input 200. For the time, we input 150 milliseconds. For the sampling frequency, 3000. And then if we press plot, so there we can see the graph. So when the user wants to input another values, just press reset, and the values will be reset to 0. So again, we add 750 samples, 250 amplitude, 200 milliseconds, and 5000 sampling frequency. And then if we press plot, we can see another graph for the exponentially decaying signal. So that's it. Thank you for watching.